Hi everyone, welcome back to my math tutorial video. In the previous video, I covered how to solve quadratic equations by factoring. Today, I'm going to talk about quadratic formulas and discriminant, delta. So we all know that the general expression of quadratics is ax squared plus bx plus c equals 0. And the quadratic formula is negative b plus minus square root of b squared minus 4a times c over 2a. So the a, b, c come from the coefficient of the quadratics. And before we move on to the examples, we have to mention that all solutions are real numbers. Okay, so here's our first example. 3x squared plus 6x minus 5 equals 0. And this is also the last example from previous video. We were trying to solve this problem by using factoring, but it turned out that it didn't work. So today we can try to solve it by using quadratic formula. So our A is 3, B is 6, and C is negative 5. So applying the quadratic formula, we have x1, 2 equals negative b, which is negative 6, plus minus square root of 6 squared minus 4 times 3 times negative 5. Okay, and this over 2a, which is 2 times 3. And now we need to simplify it. We have negative 6 plus minus square root of 36 plus, since there are two negatives, this is 12 times 5, which is 60, over 6. So here we have 36 plus 60, which is 96. So how do we simplify it? We know that for even number, we can always divide it by 2. So now we have 2 times 48, and we can do it again. It's 2 times 24, 2 times 12, 2 times 6, and 2 times 3. So now there are 2 to the power of 5 times 3. So there are 6 factors here. So this is going to be square root of 2 to the power of 5 times 3. And then we can do 2 squared times square root of 2 times 3. And the final simplification is 4 square root of 6. Okay, so we put that here. So it's negative 6 plus minus 4 square root of 6 over 6. And we can simplify this. So we can cancel out the 6 here. So it's negative 1 plus minus 4 over 6 is 2 over 3. So we have 2 square root of 6 over 3, which is the final answer. So x1, x2 equals negative 1 plus minus 2 square root of 6 over 3. So we couldn't solve this problem by using factoring, is because this is not integer, right? So we couldn't solve this problem by factoring. And let's see the example 2. So we have 4x squared minus 12x plus 9 equals 0. And we can do the same process again. This is a, which is 4, b is negative 12, c is 9. So applying the quadratic formula, we have x1, 2 is equal to negative b, which is negative 12 plus minus square root of b squared, that's negative 12 squared, minus 4 times 9 over 2 times 4. So we can simplify it. This is negative, so this is positive. 12 plus minus square root of 144 minus 16 times 9 over 8. So 16 times 9 is 144. So it means that here we have 12 plus minus square root of 0 over 8. So we would have only one answer, which is 12 over 8, which is 3 over 2. So we won't have two solutions. Instead, we will have two identical solutions. So we say x1 equals x2 equals 3 over 2. So the final answer is x equals 3 over 2. And let's do the last problem. Example 3. So we have negative 5x squared plus 9x minus 6 equals 0. So a equals negative 5, b equals 9, c equals negative 6. Applying the same quadratic formula, we have x1 or 2 equals negative b, which is negative 9, plus minus square root of b squared, that's 9 squared, minus 4 times negative 5 times negative 6 over 2 times negative 5. Let's simplify this. It's negative 9 plus minus. This is going to be 81. 26. So times 6 is 120. And there are 3 negatives, so it's minus 120 over negative 10. And then simplify it. We have negative 9 plus minus negative 39 over negative 10. We're having an issue here. The square root of negative 39 is not a real number, right? So square root of negative 39 does not exist. It means that the solution here does not exist. So there is no real solution. So next, I'm going to mention the discriminant of a quadratic. So how does the discriminant work? So the discriminant will determine the number of roots of solutions in a quadratic equation. And what is it? Its general form is delta equals b squared minus ac. And this part looks familiar, right? This is actually a part of quadratic formula. We have b squared minus 4ac, right? And this is over 2a. So basically the stuff under the square root is our discriminant, delta. There are 3 different cases of discriminant depending on the sign. It can be negative, 0, and positive. So the first case here is when delta is negative. So that means the equation has 0 real solution. And then when it's 0, means the equation has only 1 real solution. When the delta is positive, means the equation has 2 real solutions. So the first case is pretty much like our example 3. And the second case, only 1 real solution, is example 2. The last case is exactly first example. And here's the summary. If the quadratic equation can be solved by factoring, then we can apply the quadratic formula, which is -b plus minus square root of b squared minus 4ac over 2a, where b squared minus 4ac is the discriminant that determines the number of real solutions. And here's our delta in 3 different cases. So I highly recommend that you can calculate the discriminant delta first to determine if this quadratic has any real solution. If delta is non-negative, you can try either using factoring or using quadratic formula. So the delta here works as an indicator that tells if the equation can be solved or not. So this is pretty useful when doing the quadratic equations problem. Okay, I think that's pretty much for today, and I will see you guys in the next video. Thank you for watching.